Welcome to this tutorial on RT, which will deal with using multiple probabilistic models together with reliability analysis. In this example, I'm going to start with two predefined input files that you will find online. One is called a multi-model example, and the other one is a structural model that would enter into this example. I'm going to start by loading the multi-model example file by drag and drop. You could also open that by going to File, Open. What I'm going to do next now is to look at the domain and focus first not at the random variables or some of the other parameters like the responses, which I will return to, but first on to the locations. So there are a number of locations that are defined, and that's going to be the starting point for this tutorial. I'm going to view the map so that you see where these locations are on the map. The two first locations that I'm going to show you on the map are going to be the endpoints of an earthquake fault. So here's the map of the Pacific Northwest, and I'm going to start with the fault line 1 location, the fault line 2. So those are going to be the two endpoints on earthquake fault line. I'm also going to show you some of the building locations. I have three buildings in this multi-model example, and they are located in Victoria and in Vancouver, British Columbia. What I'm going to do next is to look at the models. First, I'm going to have a location model that's going to generate locations of hypocenters along this earthquake fault. There are input parameters, for example, the two locations that I just showed on the map, and other parameters that are defined as random variables up in the parameter list. Then I'm going to look at the magnitude model. Same thing. That is a model that will generate magnitude realizations given a number of input parameters. Again, most of them are being random variables further up in the object pane. Then I'm going to the intensity model, and that takes the three building locations and a number of other input parameters, and that will generate intensity values at the locations where these buildings are located. That leads me to going to the responses, where I want to show you the generic responses. These are, for the most part, auto-generated by the models below. For example, the intensity model generates these three responses, 1, 2, and 3, namely the intensity at the three building locations that have been given to that model. Further, I'm going down to the ST model. That is a structural model. ST, as you may know, is the structural analysis software that is posted together with RT on our website. And it takes as input file this file that I have on my computer disk. I keep that file in the same folder as the other one, in fact on the desktop in this situation, which is a convenient way to have them run together. Let me also briefly mention that I have some simple damage curves that models building number 1 and building number 2, while building number 3 is this more complex, more comprehensive structural model where the response, the displacement response from that is going into some simple damage curve that will give me the damage as a function of that response. Without going in detail, and also emphasizing that this example is not meant to be the realistic example, that is for later publications, but it's a demonstration of using multiple models together in one analysis. Having said that, I will point at the very last consequence model, namely the building repair cost for the three models. Please look at the model manual on the website of RT to see more details about all these different models. Let me just say that the response from these cost models, let me see if I can find them in my response list up here. Here's the repair cost for number 1 and for number 2. I also have a repair cost for building number 3, and they all go into the function that I've specified. So here's my function. That is the sum, in my expression here, is the sum of the cost, the repair cost for each building. So let me start now by doing an analysis. The first thing I like to do is to, when I start the analysis here, is to go to function evaluation. I just want to evaluate the function, this function that I just showed you. I'm going to do it at the mean value of the random variables, and I'm pressing OK. you will see on the map that a new location has been generated. This is in fact the mean location of the hypocenter of the earthquake, and you will see that the function value is 2.5 million. So that is the loss at the mean value of the random variables. What I'm going to do next is I'm going to do a sampling analysis. I am going to do a histogram type analysis on exactly this function that I defined. You will see that the histogram is being formed here. Samples are counting up to 100, so in this input file I only have 100 samples. It's very little, but the reason I didn't want to do more is that all these realizations are created, as you will see here. If you see my cursor, you will see that they are created along the earthquake fault. So these are now the random realizations that occurred, and when I do visualize them on the map, the analysis goes fairly slow, so that's why I stopped at 100. What I want to do now is to investigate the tail probability a little further. I'm going out in this tail that is of course very inaccurate in this 100 sample histogram, but I'm going to go in at in fact here around 50 million, and I'm going to investigate what is the probability that this loss, the total loss, exceeds 50 million. I'm going to start by closing all the windows to let the analysis go a little faster. I'm going to then start a form analysis. Well, before I do that, let me change the function to make it a proper limit state function, namely by asking what is the probability that the loss exceeds $5 million, namely 5 to the power 7, 5 times 10 to the power 7. And that's my limit state function. I'm going to subject that to form analysis, but I want you to look at something interesting happening here. I have predefined my analysis tools. I press enter, and you will see that this form analysis does not converge. It goes out to a far distance. In fact, 16 you may see on the screen here is the distance from the origin to the trial points, which is a large distance, and it didn't converge. This is something you will find if you are not careful when you select your step size in the search for the design point. Instead of using the fixed step size, I'm going to use the Armegio step size selector. So let me go to my solver and change that. So here I'm switching to the Armegio, pressing enter and running the analysis again. And this time you will see from the red line here, it converges to a reliability index of a little over 2. In fact, let me see here in the output window, 2.17 is my reliability index. What I would like to do now is to verify that by importance sampling around the design point. So then I'm going to my analysis tools and the random number generator, and now I want to generate random numbers around the current value of the random variables, namely the design point that it just converts to right now. And I go to analysis, sampling, and I change the accumulator to the failure probability accumulator, and I press OK. You will see now that the number of samples increase in the output window here. You start counting up samples, and in the graph that's being displayed here is the coefficient of variation of the sampling result as it's decreasing. I can speed this up a little bit by going to my failure probability accumulator and setting the output to minimum, because in the output window it is being printed the sampling number, and you will find that this line here starts going a little faster, so the sampling it's taking a little less time here. And I remind myself that the reliability index from form was 2.17 approximately. So as soon as this analysis now has made it to 0.05, the target coefficient of variation that I'm looking at here, 5%, I can go down in my output window and look at the reliability index from this analysis, 2.09. So a slight correction compared to my form result. The last thing I want to do in this tutorial is to look at the random variables, and the interesting thing is that now we can rank them and see which was the most important random variable in this analysis. So opening this branch here, ranking by the gamma importance measure, and there you'll see which parameter is the most and which is the least important. Thank you.